I appreciate the chance to talk a little bit today about our latest release, Syndeia 3.4, and how Aras Innovator is part of that. In terms of the agenda for today, I do want to set the stage a little bit as to what we're trying to accomplish as a company, and then dive as quickly as possible into the actual demonstration of the Syndeia software, specifically with a focus on how Aras works within that framework. I'm going to hand off to Manas during the demos and let him do the last couple of aspects of that and then close up the talk at the end of that. For us, since we got started, model-based systems engineering is about this idea of being able to create a single unified digital model of the system, a single authoritative source of truth. And doing that in an environment where the system data is spread over a large number of different models and data repositories. So one solution to that conflict between single and multiple is this idea of creating a fine-grained network of connection between model elements and different tools so that we have the ability to begin to approach this idea of a single unified model. And of course, if you're going to do this in a practical environment, there's some needs that you have to be able to address. Number one, we want it to be an open system, an open network. That is, multiple different vendors can be part of this. Organizations and consortia of organizations can work with a wide range of different best-in-class or legacy tools in order to be able to work together on that. We want it to be both accessible and secure. Accessible in the sense that people can access the information they need wherever it lives in the digital thread. But at the same time, if they're not authorized, they can't get at that information. Dynamic and multi-branch simply says that this network is going to be constantly changing, and we have to be able to track those changes. And we have to be able to deal with the fact that there's very likely to be multiple variants of this system that have to be managed concurrently. And finally, scalable, of course, is that it has to be able to deal with real-world systems projects that have millions and millions of different elements and relationships. So these are all some of the things that we're working toward as we've developed this product called Syndeia. And again, as I've mentioned in the past, Syndeia is from the Greek for the practice of bringing things together. And that's what it does. It builds this federated system model between many of the different engineering tools that are part of the systems development process and provides services for not only making those connections and updating those connections, but also to be able to visualize and query, ask questions of this federated system. And so one of the common terms right now for these federated systems is a digital thread. And so when we talk about a digital thread, what we're talking about is something that looks sort of like this. You have a bunch of individual domain models. They contain artifacts. Those artifacts have attributes. And they internally, within those domain models, have relationships. And all of those are typically managed by a particular tool. There is also the possibility of creating connections across those different domain boundaries. We make the distinction, and you'll hear me talk about this, between an intra-model relationship that's inside of one of these domain models and an inter-model relationship, the dashed red lines in this. And this is really where Syndeia begins to come into play because Syndeia can create and manage these inter-model relationships. But the digital thread comprises all of this, the intermodal and intramodal relationships, the artifacts and their attributes. And that if we are truly going to get our hands on this digital thread, then we have to be able to look at all of those things and have access to all of those things within a single framework. And that is ultimately the goal that we're trying to achieve. Now, in practice, we're on the path towards that. The specific tools that we have within the Syndeia 3.4 release, which actually came out 2 weeks ago formally, are shown on the periphery of this particular slide with Syndeia in the center. Among the new integrations that were released in the 3.4, we do have Aras Innovator for the first time. We also have Teamwork Cloud is new, Confluence is new, GitLab and Bitbucket are new. So we have a number of different included integrations that are new in 3.4. We also have, for the first time, a SysML 2.0 integration. We've been very active with the object management group in the development of the SysML 2.0 spec. And really one of the first commercial realizations of that is in the 3.4 release, where we have the ability to integrate SysML 2.0 models through the API for SysML 2.0. So that's the framework for the tools that we integrate together. And then I want to talk a little bit about the architecture of that, because that is also evolving. In fact, that's been a major effort that we've had over the last couple of years, was the ability to grow the architecture. It's really a hybrid architecture. We have a network-enabled component called Syndeia Cloud. And when we say Syndeia Cloud, this is not a cloud that we manage. This is an on-premises server component or on a private cloud behind the customer firewalls and all of that. And this Syndeia Cloud component contains the graph database that manages the intermodel connections. And it has a set of services. It's a microservices architecture, which not only manage the database and the API communications, but also allow Syndeia Cloud to talk directly to at least some of the engineering applications that we integrate. That is, if the engineering applications can be dealt with directly in their repository through their own API, Syndeia Cloud can interact with those directly rather than through a client. So Syndeia Cloud has a REST API, and the other half of Syndeia is the clients that can interact with Syndeia Cloud. Probably the client that we started out with and that you've seen before was the Syndeia plugin for Magic Draw or for Rhapsody or a standalone client. That's still part of our architecture. It also gives us the ability in some cases to talk to local engineering applications. But we also have, and this has been evolving over the last couple of iterations, a Syndeia web dashboard. That is, on the user machine, we can actually interact with Syndeia Cloud through our web browser and make use of the capabilities of Syndeia Cloud directly. And mostly that's what I will be demonstrating today. And then there's a third option. The REST API for Syndeia Cloud is very well documented. It's entirely open. And so we have the ability to be able to interact through custom scripts, custom applications, third-party applications. One of the important aspects of this integration framework that we're trying to build is that every user has a different set of use cases, a different engineering workflow, a different set of reporting requirements, and we wanted to be able to create a very flexible interface that they could use to set up the digital thread the way they need to set it up and have it do what they need it to do without us trying to put a one-size-fits-all solution on the marketplace. So Modus will be talking about some aspects of that, particularly using Jupyter Notebooks to be able to access the information in Syndeia Cloud about the digital thread. That is really the introduction that I wanted to do. So at this point, I really want to be able to go on and talk about the demos itself. For the purpose of this demo, I created a simple digital thread just to be able to show you some of the things that we want to be able to do. And here's the schema for that. We're talking about a MBSE process where somebody starts with requirements, and we're going to use Jama Connect as our requirements management tool. It could be Doors NG or several other possibilities. The requirements drive architecture. The architecture in this case is going to be in SysML, and we will be working with a SysML model that is actually in Teamwork Cloud, as opposed to loaded into an actual running license of Magic Draw or Cameo. The architecture then drives the software and the hardware development. And we're going to use GitHub as the software manager in this, but we're going to use Aras Innovator as the hardware PLM system that's going to drive a lot of the detailed hardware development. And then farther downstream, we have additional applications. We've got TestRail, which is a test management solution where you can specify your test suites and manage your test results. We've got Jira, which we're going to use as a project manager. It's going to be a place where we can log progress in completing the different tasks that are part of our system development. And then I'm going to use Artifactory simply as a place where I'm going to store simulation results tied to some of the designs of the hardware designs in Aras. Again, there's nothing special about this particular schema. It's just the one that we put together to show you a range of different tool types and the ways in which they might interact together. With that as an introduction, now I'm looking at my web browser. I'm going to log into Syndeia Cloud from outside. And we're going to actually go and start to look at Syndeia Cloud through the web browser interface. The first screen is just basically a dashboard with some basic simple metrics about the number of digital artifacts that are part of our digital thread database, part of our graph database, what type of artifacts they are. We can go into the data model at some stage if that's of importance. But what I want to do first is actually be able to go and look at the integrated repositories. Here we are on the repositories page, and where we can actually see the different repositories that we have access to in the different categories. If we're dealing with Aras Innovator, one of the things that we need to do is make sure that we have our credentials logged into Syndeia, if we choose to operate in that fashion. In other words, when I created that repository connection, I included the information that Syndeia is going to need to be able to access Aras on my behalf. But we have similar things for many other tools. For Jira, in the case of Jira, there's actually 5 different repositories, Jira repositories, that we could have access to. Or Teamwork Cloud, similar, there are multiple repositories, all of which could become part of our digital thread. But we're going to start off with the Aras Innovator, and we're actually going to go, and what we're doing now is that we are accessing the contents of the Aras Innovator repository via the Syndeia Cloud REST API. So not directly, but indirectly, in a sense. And so we can see real-time the contents of that. And again, we've got multiple products here. And if we expand those, we'll go out. Now, this information is not stored in Syndeia Cloud itself. Syndeia Cloud is going out and getting this information real time in order to be able to see this contents. And we can go down and we can break down through the different levels here. We've got an electrical assembly and so forth and so on. And we can do the same thing with some of those other repositories. If I go to Jira, I can see the contents of that, where we've got our Jira projects for the autonomous driving system, and so forth and so on. The same is true with Teamwork Cloud and the other tools that we're working with here. So again, we'll go back to Aras, and we'll explore a little bit with what we can actually do through the Syndeia Cloud interface, the REST API. For example, if we choose a component and go over to the details page, we can actually see a number of the attributes about that component. Now, generally, these are the attributes that Syndeia uses and stores for that information. But potentially, we could go out and get all of the attributes that at least are available, those that are available through the API for Aras, and be able to show those. We can also search the repository. I'm going to let Manas show some of the search capabilities a little bit later, because we can use the Aras query language to search. But we also have the ability simply to click on one of these items, go to More Details, and actually launch the Aras Innovator browser interface directly. So rather than going via Syndeia Cloud now, we're actually allowing us to look into the Aras Innovator repository directly, and we're waiting now as that boots up and allows us to get in. Again, this only works if I have credentials personally to be able to access Aras Innovator, and only those parts of Aras Innovator that I have the ability. So here's our braking system, and we have the different aspects of that. We can do the same thing with Jira. I can click on his Jira issue, and if I have access to the Jira repository, I can launch Jira and see the full contents of that. But what I want to go on now is talk about how we can actually look at relationships through this interface. Let's go to the electrical assembly. The electrical assembly is midway down the parts hierarchy. And if I go over to this other icon on the right side, Relations, I can actually see the different artifacts that I am connected to, the nearest neighbors in the Syndeia digital thread. And that includes both the intramodel connections, those that are internal to the Aras repository, and the intermodel connections, those that Syndeia has created between that particular Aras element and outside elements. So if we look at the intramodel connections initially, we can see that we have connections to vehicle processors, sensor subsystems, in other words, the subunits of this. And we also have the connection, essentially upstream, to the vehicle part. And so these internal connections from Aras are available to us through this. And depending on the tool that we're working with, there can be other types of inframodel relationships that can be displayed here as well. And the intermodel connections are something slightly different. In this case, we have a connection between the Aras element and an ECAD file. This is one of the artifactory files, presumably simulation results or design results. And another to a GitHub code file. In other words, we can create a connection between a hardware element and a software element that perhaps works with that hardware element. So all of this information is available directly through the interface, and we have the ability not only to look at it through tabular format here, we have the ability to look at it through other forms as well. Let's go to braking assembly. Braking assembly is similar. In this case, however, there's only one internal connection, upstream to vehicle, but there are 4 different connections to other tools, including test rail, including Artifactory, including, in this case, Teamwork Cloud, and including Jira. So this particular braking assembly is already connected to multiple different elements. What if we wanted to add another intermodel connection to that? We can actually do that through this interface as well. I can go up to this Add icon, and I open a new window that lets me decide what I want to connect it to. I'm going to choose a particular project. A project is basically Syndeia's way of separating out different systems. And I'm going to connect it to a GitHub artifact. So I have a GitHub repository already set up. I can then go ahead and I can look at the contents of the GitHub repository real time. I can take a look at this. Of course, it's configuration managed, so I'm looking at branches or commits. And I can go down here and I can go and I can start to look at the different elements there. And if I want to create a particular connection here, presumably the braking system may be part of the obstacle avoidance software system, I can create a new reference relationship. And now that becomes part of the digital thread that Syndeia is managing. We can see that here now. We can also look at this graphically. This is another new feature in Syndeia 3.4. It's called the Digital Thread Explorer. And so to reach that, I'm going to go from this tree view of the system to a graph view. And when I first launch the graph view, I see the element I just selected, braking assembly, and I'm going to expand it, which means I'm going to display all of the nearest neighbor connections, including that GitHub connection I just made, the test rail, the Artifactory element, braking subsystem, which is a Teamwork Cloud element, the Jira element. And again, I can actually launch all of those interfaces, at least the ones that have web interfaces, by right-clicking on that element and saying more details. I can do it from this diagram as well as from the tree view. And I also see the intramodel connection to the uphill vehicle. And so what happens if I start to expand it further? This is an interactive exploration tool, the Digital Thread Explorer. So if I say, well, what about this test rail element? This is a test suite. What is it connected to? And if I expand that, I can see, well, it actually expands. The next level is called test cases. It's a section. And if I wanted to go ahead and expand that, that section contains a couple of different test cases. So I can explore further in that direction as well. Similarly, with the intramodel connections, if I want to see more about what the braking assembly is connected to within the Aras repository, I can click that as well, and I can expand that. And now we can see there's a lot of sub-parts within the vehicle, but it also has its own connections. It has an upstream connection to the product, and then it has a test connection, or this is a Jira connection actually in a tool called Zephyr Scale, but it's another test management solution. And then you have a SysML 2.0 element that it's connected to. So with this kind of an arrangement, we can interactively expand and look at the neighbors, the connections of any individual element within our digital thread. And so we can use this for micro exploration in a sense. But the other aspect that I wanted to introduce here is more the macro view. One of the reasons for building the digital thread is that it gives us a handle on the entire system development project. It lets us access the information for documentation. It lets us monitor real time, not only what's been done, but what's been connected into the digital thread. And for that purpose, we actually want to use a somewhat different tool. We want to talk to the graph database with pattern matching queries. In other words, we want to be able to ask questions of the entire digital thread and get back answers relatively quickly. So what I'm going to do is simply ask the digital thread to show me all of the Aras Teamwork Cloud connections within the system. I'm going to enter this with a existing query that I've run, which is simply looking for that. It's looking for all the connections between Aras elements and, in this case, Aras parts and Teamwork Cloud elements. And so when I run that, I will get a result back that shows me all of the examples of that particular pattern. Now, this particular query has not been optimized particularly, as one of my technical colleagues pointed out. Let's change the layout. We can change the layout, color, all that good stuff. But here are our Aras Teamwork Cloud connections. And we can see very quickly that there's a number of them. Some of them are one-to-one, some of them are one-to-many, or vice versa. But all that information is there. We can see the same information in a tabular format. We can also export it as a JSON, structured data file. It gives us all of the same information in a very standard pattern. So we have a way of being able to use the information that we're getting from these queries. So here again, we're just looking at nearest neighbors, but if we want to, we can go to slightly more complex types of patterns. Say we want to look at all of the patterns that match a Teamwork Cloud element to an Aras element to a test rail, test suite. In other words, find out how many of the Aras components have actually had testing defined for them. And so we'll modify the query. Again, we're looking for not nearest neighbors, but extended chains of connection. And of course, it can be as long as we want it to be able to do. And in this case, we're saying, okay, here's our Teamwork Cloud element. Here's our Aras element. Here's our test rail. And for all of the examples for that, again, we can do this in a tabular format as well. But you'll notice, of course, here there's only 3 examples that follow this particular pattern, whereas when we looked simply at the Teamwork Cloud to Aras relationships, I believe there were 9 of those. So part of what this is able to tell us is what's missing. In fact, we can even reformulate the query so that it explicitly shows us cases where things are not in place. If I wanted, for example, to take a look at, show me all the patterns where Teamwork Cloud is connected to Aras, is connected to Jira, but the Aras is not connected to an Artifactory simulation results file, I have the ability to generate a query like that as well. And so we can rearrange it to make it a little prettier, but it shows us all those cases where we have Aras elements, and they are connected to both Jira and to Teamwork Cloud, but they're not connected to Artifactory. And so this is explicitly what's missing. What you're seeing today is really a first step. This is the first time Aras has been part of Syndeia. Our focus initially has been on integration for purposes of data analysis rather than for data transform. And we'll talk more about next steps towards the end of the presentation. But at this stage, Manas, I think I want to turn it over to you.
Thanks, Dirk. I want to talk about the API for Syndeia Cloud and show you a demo. But before that, I did want to cover something here. Dirk mentioned I want to talk about search. We're constantly thinking of how people enter Syndeia Cloud, how people get into Syndeia Cloud. And people who work with Jira and other repositories, we know how that works, what the users think, how they view things in Jira. And so we want to make sure that the interfaces in Syndeia are very familiar, so they have an easy entry point, a familiar look and feel. With Aras, we know that the search is a key part of accessing Aras. When you're in Aras Innovator client, you start to search for parts and products and other things. And so we thought that the search was a key part of this. So if you click on the search tab while you have the Aras repository selected, you can see you can search for items of any type. Now, this was very important for us because we know that people would customize Aras Innovator. They have their own item type that they would create. So you want to make sure that we dynamically fetch any item type that the customer or user would have customized or built. So here I've picked up part here, and this is dynamically fetching that list from Aras Innovator. I can specify search items by item numbers, or part numbers in this case. So if I look for a part with that part number, WA101 bot, if I do that by item number, I can fetch the item. And here I can get the body. And the same functions that Dirk was showing you are available to you from here. I can take this to the graph view. I can look at its details. I can create relationships to Jira or Jama or Doors NextGen or any other repository. And I can also go to Aras directly from here. So we don't want to get into that right now because you've seen that. If I go to the filter part of it, I can write a filter query. And as you know, that this is provided by the Aras API, and this converts into the AML syntax internally on your server. So I can write things like classification equal to assembly and state equal to released. If I type that, and it'll search all parts which satisfy that filter. If I remove the filter and just say, give me just assembly, I can do that. So you can type in any filter that the Aras server accepts through its API, and you should be able to search for it. And so that is important because you could have users who have different item types, and they can type their own queries and use that as a starting point versus products and parts on the tree as their starting point. So I want to show you that first. I want to talk about the API. Syndeia Cloud is an API-first microservices platform. What I mean by that is the API is very near and dear to us. For us, it's a key enabler for an open digital thread. Without an API, there is nothing called open there. When we first released Syndeia Cloud's first version, 3.2, back in 2018, all we had was a backend store and an API. We knew all along that without an API, we would not be sharing this with our customers because they're all very heavy-duty power users. And when we released Syndeia 3.3 in 2020, we brought the capability of doing graph queries using Gremlin language or through a query builder that Dirk was demonstrating. And that also first came into the platform through the API, and then our clients used it. And then even for 3.4, where a majority of Syndeia's capabilities are now moving towards Syndeia Cloud, the integrations that you saw with Aras and Jira, they're all part of Syndeia Cloud, and that's also available through a REST API. We do not make anything on Syndeia product platform which is not exposed to the API. And our own clients, our own Magic Draw plugin to Syndeia Magic Draw plugin, or the Syndeia Rhapsody plugin, or the Syndeia standalone desktop app, or the Syndeia web client that Dirk was just demonstrating, uses the same API. So if our API breaks, our tools break first. If our API is slow, if some calls are not performant, our tools bear the brunt of that first. There is no other way of accessing Syndeia Cloud but through the API, and our tools we fashion them to do it that way. And that's really important for our users because for our users, the API experience is as important as the front-end UI and the dashboard experience. Many of our users, actually I would say most of them, are building custom apps in-house for report generation, design reviews, project management. And so they want all of Syndeia's capabilities to be available through an open, cleanly documented API. And a lot of the users now have their own in-house digital engineering platform. They're not taking platforms from one vendor, but they're building their own platforms where they want the vendor tools to plug and play as ready-to-integrate services. And that's true of the requirement from Syndeia. In many cases, many of the users who are using Syndeia, they don't even know at the company that they're using Syndeia because it's plugged into their environment as through a service, through the API. So here's one example. One of our customers uses OpenMBE, which you may have heard of. It's an open source model-based engineering framework, started out at NASA JPL, then added Boeing and other places. They've kind of adopted very heavily, but they create like these web version of documents, right? Model-based exposure of documents, generate or provide documents in a model-based fashion. And one of the common things they want to do is to generate traceability reports in a table. They plug Syndeia, they call the Syndeia's API at the backend and get intermodal relationships through it, along with the hyperlinks, and generate tables like this to say, okay, what subsystems in their architecture are linked to what models, what PLM parts, what tasks in Jira, and so on and so forth. And this kind of report usually would take them days to assemble, but they've kind of automated the process using Syndeia Cloud API. As the digital evolves, they generate these on the fly, almost in automated fashion. Every 6 hours, the data gets refreshed as per the schedule and this table gets updated. So the system engineers or the project management team is getting to see the latest views. So again, this is not a capability we built, but because of the API, the customer itself, they built it, they included it in part of the digital engineering tool. So what comes to the Syndeia Cloud API? Well, very first thing, we expose an API as an open API spec, which is available through Swagger Doc. And that includes not only the core capabilities in Syndeia, but also our integrations through a common digital data model. So our Aras integration that we built, that's exposed through our API. Anyone can use that to do the same calls with Aras that you were seeing Dirk do on the web client. I want to show you a glimpse of that if I can here. So if you go to Syndeia web dashboard right here, you can just go to the help menu and you go to the Swagger doc, and right here you have got the full API documentation available as Open API Spec 3.0. How do you authenticate? How do you get repositories, containers, artifacts, relationships? And then how do you get work with Aras or Artifactory or Bitbucket or Jira? Anything that we are doing on the web client, all available, exposed through the Syndeia Cloud API. Now from the API, we take it a step further. We think the API is important, but a lot of our users are buried in their own favorite programming languages. So we also go ahead the next distance for that last mile connectivity to say we're going to generate API clients for you. So if you're a Java developer or a Scala developer, we generate a Scala or Java client for you. If you're a Python developer, we generate a Python client for you from the API. So they can use Syndeia Cloud API through their familiar programming language. On the right-hand side, you see two examples, one in a Jupyter Notebook, which is very popular in the data science community, to be able to interactively work with data coming in different parts of the enterprise and wrangle the data, play with the data, run analytics, do visualizations, queries, reporting, and all sorts of cool stuff, make sense out of data. So we have Syndeia Cloud available as a Conda package API to the Jupyter Notebook environment. On the bottom, you see an F#.NET notebook running in VS Code, also using the Syndeia Cloud API, using our API to fetch data and generating charts and plots. And I want to show you this live to you. So I'll switch over to the web browser, and I have a Jupyter Notebook here, as you can see here. And what Jupyter Notebook is, if for those of you who are not familiar with, it's very popular in the data science community, but allows users to interactively play with services and their APIs and fetch data and do queries. So I'll walk you through some examples of how we can use this with Syndeia Cloud and with Aras in particular. So the very first part of it, I have some code where I import some standard libraries. Then we connect to the Syndeia Cloud server, ask for my password. I type in my password, initializes the API. So in this case, it signs into Syndeia Cloud, generates a token. And from here on, I start interacting with Aras. So it's now using Syndeia Cloud's API to talk to Aras and get data from Aras and present the data in any shape or form that I want to. So here, for example, I'm connecting to the Aras server and signing in. Well, I'm first connecting to the Syndeia Cloud server and asking how many Aras repositories are available through Syndeia Cloud. And if I run this, it'll make a call through an API and says there's only one repository, which is this server, and its repository key is 156. And then I sign in to that repository with a familiar username and password that you may know, but comes out of the box, and it generates a OAuth token. So now I'm signed into the Aras repository through the Aras API. And now, again, through all these calls, I'm just calling the Syndeia Cloud API. The first one, I make a call to say, get me all product items in the Aras repository, that specific Aras repository. If I run it, I get a response, and there are 5 products. Here are the keys or the product numbers or the part numbers, and here are the names of those parts. Then I said, let's run some queries through the queries that we just ran. So for example, in this case, I want to get all assembly parts that are in preliminary state. So I've passed this familiar looking query, which, as you know more than me, that this will convert into an AML syntax at your server and generate data and come back through the API. So here in this case, the call is going from a Jupyter Notebook to Syndeia Cloud API, which is then formulating that and sending to Aras server, bringing back the results and presenting it. So I'm doing 2 queries here. Give me all assemblies which are in state preliminary, and give me all assemblies that are released. If I run that, I get a data dump here, which says, okay, you've got 23 assemblies that are in preliminary state, and you've got 2 assemblies, these item numbers and names, which are in release. And I run the same query for components and say, give me all components that are in preliminary state, and give me all components that are in release state. Run that, and I get that response. Okay, 10 components are in preliminary state, 6 in release state. And I say, okay, just plot the data. And so here's very simple. I'm using graphing library available with the Jupyter Notebook to say, generate a stacked bar chart. I fetch data from Aras through Syndeia Cloud's API, and then eventually to Aras API, and I'm presenting that in a useful fashion that I would present to a stakeholder or my management or generate reports out of it. So in this case, you see a stacked bar chart. The first bar is the components bar, where you can see the components that are in preliminary state versus release state, and assemblies that are in preliminary versus release state. Just simple insight tells you that there are a lot more assemblies that are in preliminary state and not have been released yet. Very simple, but just a picture is worth a million words. The other one I want to do is let's say, okay, I want to now start hunting for part bomb relationships from a given Aras part. So I've given here the part number for the powertrain, and I ask Syndeia to go and fetch the part bomb relationships from this part. And if I run that, it generates a table and present to me in a tabular format saying, okay, for that powertrain, you've got an engine, which is part bomb relationship with the ref test engine, which is pointing to the engine part, transmission, differential, and 4 wheels. And if you can see in this table, these are hyperlinked. If I click on the engine right here, this will open that engine in Aras Innovator right from Jupyter Notebook, right? So I'm not doing anything fancy, but just using the same API which you were seeing in action, the web client, and you saw Dirk right-clicking on a graph, Dirk right-clicking on a node in the tree. Now we're generating reports in Jupyter Notebook environment, a data science environment, and then be able to open this in Aras Innovator right here. Now we say, okay, we've looked into the data that's within Aras. We've been able to get a part, do searches, do queries, and navigate relationships through the Aras Syndeia Cloud API. Now we want to look at relationships that are crossing the boundary of Aras, right? Things that are connected from the Aras part to some other things. And now we come to a specific part, which is the vehicle one body. And you saw Dirk was running those graph queries in the Syndeia web dashboard. And again, as always, that graph query was running as an endpoint in our API. You can call the same graph query endpoint through our API. So in this case, I am making graph query and saying, for this vehicle body, can you give me all of the outgoing and incoming relationships in the project that Dirk was working with? So just fetching that data, all outgoing and incoming relationships from the vehicle body part in Aras, and then displaying it in a tabular fashion. If I run this, I get the data, and I then render it in tabular fashion. So you see a table that's come out and say, well, for the vehicle body, there are no incoming relationships, so it's not a part of any target of any relationships, but it's a source to 4 relationships. That vehicle body is linked to something, which is an ID. This is coming from Teamwork Cloud. There's no web client for Teamwork Cloud server, so there's no hyperlink there. But that vehicle body is linked to an MCAD document and also a CFD document on Artifactory. Again, hyperlinked. If I click on this, do that, right-click and say Open a new tab. Now I'm in Artifactory, and I'm looking at that file, which was part of a simulation result and published by my team. So again, that data is accessible through the web client. That data is accessible to you through an IPython Jupyter Notebook. And this is just the beginning. There's tons of visualizations, tons of reporting capabilities that you can do that we cannot, even as providers of a tool, we can't even fathom what our users do. And every time we talk to our users, they show us some really cool new visualizations using our API, which frankly, we haven't tried. They are very good at it, and they do this. And so we're trying to follow them and saying, let us use these kind of environments and see if our API stands to the test of getting data which can be presented in different ways and forms, however our users may like it. So we go back to the deck. I wanted to cover a couple of things before we move on. This is just the beginning, as I said. We are also working on automated pipelines, like automated CI/CD pipelines using Syndeia Cloud API. And so, for example, this is very early, and we want to show Aras as part of this in the next few months. But for example, users can fetch data from Jira, fetch data from GitHub, do analytics on the data, present a report, and exit the pipeline. So they can do automated schedule runs through Jenkins or some kind of an equivalent CI/CD tool. And so we want to bring the whole capability of continuous integration, continuous development to systems engineering and engineering in general that the software engineers have had for a while. In the software engineering world, you do these test pipelines where your code gets compiled onto a server and tested overnight and scheduled. We don't have similar capabilities in the engineering world, and we want to do that and make that possible through Syndeia for model-based engineering. There's a lot of stuff out there. We have a help desk. We have all of our online user guides and tutorials are online. You can go and watch that. It's all publicly available. There are videos, tutorials, exercises to get people started with Aras Innovator and Syndeia integration. And that's it for now. I'll stop and open for any questions you may have.